content. I'll just take up 5 minutes in just revising the things we have done in the previous class. Okay, so let me share the screen with you people. Okay, so far we have studied about the structural testing. We started with the structural testing, and in that we have gone through code coverage. We have gone through code coverage. What do you mean by code coverage? It will just describe you about the degree of which source code of the program has been tested. Okay, we have studied various code coverage methods. Okay, like statement coverage, decision coverage, and branch coverage. Okay, what do you mean by statement coverage? It is again a white box testing technique. You know what do you mean by white box testing technique? It is the testing technique in which you focus more on the structure of the code rather than the functionalities. So it is basically used for checking out how many number of statements in the source code have been executed. Okay. So it will basically derive you the scenario based upon the structure of the code which is under study. Okay. And we have gone through one of the formula, that is how we can measure statement coverage. That is, the formula is very simple. Number of executed statements in the source code divided by total number of statements in the source code into 100. Always express the coverage in terms of percentage. Okay, and then we had taken up one simple example wherein we just calculated statement coverage. Okay, so here whatever I have highlighted in yellow color, it indicates the executed statements for scenario 1, wherein the input values for A and B I have mentioned there. If I give those specific input, then only these statements get executed. As per the inputs given, the statement coverage here it is 71%. Okay, and you have to indicate with a diagram like this. After that, we have considered one more scenario wherein I have changed the values of A and B and I have checked out how many statements were executed in the source code. And once I know how many statements are present in the source code pertaining to the specific input, I can measure the statement coverage using the formula. Okay, what all are the things that I can cover by making use of statement coverage? I will get to know about the unused statements in the source code. There are the statements I have written, but I have never used uh, after the execution of a specific code. Okay, those things I will get to know by going for statement coverage, then dead code. Okay. And unused branches and some of the missing statements can be known to you if you go for statement coverage method. After that, we have looked into decision coverage, okay, which basically reports the true or false outcome of a particular Boolean expression of the source code. Okay, it basically checks the outcome, whether it is true or false. It is dedicated for a specific outcome to check the particular Boolean expression outcome. Okay, and it is very difficult to achieve 100% coverage over here. So we have various different methods for reporting this particular method. Okay, and here it focuses on considering various combinations. Okay, so but it offers better sensitivity to control flow. Okay. And we have gone through one of the formula, that is how do we measure decision coverage, that is number of decision outcomes exercised divided by total number of decision outcomes. We had taken a point simple example wherein I had one conditional statement. Based on one conditional statement, if it is true, where it has to go, and if it is false, where it has to go. Okay, so based on this, I had considered one scenario where the value of A was 2. Okay, here if you go through this, okay, if here basically over here focus on this particular conditional statement. If A is greater than 5, okay, what is the A value? A value is 2 here. 2, is it greater than 5? No, it has to come over here. So print A. What is the outcome of this Boolean expression? It is false, which is equal to 1, and the total number of possible outcomes for this particular Boolean expression is 2. So 1 divided by 2 is 50%. That's why the decision coverage is 50% over here. After that, let me consider one more scenario wherein the value of A is 6, which is greater than 5, and this particular statement gets executed. But what is the outcome that is being exercised? It is true, which is equal to 1. 1 divided by total number of outcomes for a particular Boolean expression. That is 1 divided by 2 again. It is going to be 50%. Okay, after that we had looked into branch coverage, where each and every outcome from a code module is tested. Okay, it's not with respect to single outcome of a Boolean expression. Here we are going to test for each and every outcome from a code module. Let it be a statement or rule. What is the purpose of having branch coverage method? Okay. Via this, you will ensure that each decision condition from every branch is executed at least once. So, this term is very important. By writing a test case, you will ensure that the outcome of a particular Boolean expression, you are going to test at least once by writing a test case. Okay, so after that, we had looked into one simple example, that is the branch coverage, how to measure. We do measure it by making use of a formula, that is number of executed branches divided by total number of branches. Okay, and we had considered the same example, that is the previous one which we had considered for computing decision coverage. Okay, see, if you come over here, you have conditional branch as well as unconditional branch. Conditional branch, there are two outcomes, yes or no. So two are constituting for conditional branch. One basically constitutes the unconditional branch. So totally you have got three branches overall. Okay, so with the above example, they have computed decision coverage as well as branch coverage. As you have seen, decision coverage remains 50% only, because the formula for computing decision coverage is number of outcomes exercised divided by total number of possible outcomes for a particular Boolean expression. Okay, so what is that? So you are going to test for a single outcome where the value is going to be 1, and for a Boolean expression we are going to have two possible outcomes, that is 1 divided by 2, which is going to be 50%. That's why here decision coverage remains the same irrespective of the value that you are going to pass for a particular source code. Whereas there is a change in the value for branch coverage. Why it is 33%? Okay, we have discussed about this. Whenever value of A is 2, let me check out for that. Okay, I had explained you this. Okay, whenever the value of A is 2, just I will explain via this diagram. 2, is it greater than 5? No. So it will just print A value. It will just print the A value. That is only one branch as per the formula. As per the formula, what is the formula? Number of executed branches. How many branches are executed? Only one branch out of total number of branches. How many branches are there? 1, 2, 3. You are going to consider even unconditional branches. That is 1 divided by 3, which is equivalent to 33%. That's why it is 33%. Okay, let me take up the value as 6. Okay, if the value of A is 6, is 6 greater than 5? Yes, definitely. It will come over here. It will update the value of A. After that, it will print the value of A. So, how many branches are executed? Here, 1 branch and 2 branch out of 3 branches. 1, 2, 3. 2 divided by 3, it is 66.66. Recurring decimal, 66.67. That is 67% approximately over here. And you are not going to have the same values for decision coverage as well as branch coverage. They will vary in the values. So you have to be very careful whenever you take up the scenario by considering the specific value for input variables for a particular code snippet. Okay? And you have to explain these things by taking up the scenarios and by measuring the coverage for each one of the things we have discussed: statement, decision, branch coverage. What are the advantages with respect to branch coverage? Okay, There are various advantages associated with this particular branch coverage since it validates all the branches in the code. Most of the Boolean expressions, with respect to the Boolean expression, the branches that are arriving or they are derived from a particular Boolean expressions are tested via branch coverage. Okay, and it will also ensure that no branch of a particular Boolean expression will lead to any abnormality in a particular program execution. Okay, then it is one of the major which removes the difficulties associated with statement coverage. Okay, and it will also focus on the areas which are not tested by the previous methods we have discussed. Okay, then it ignores certain branches inside Boolean expressions which are not so important. Okay, these are certain advantages that are associated with branch coverage. Next, we have something called condition coverage. These three things are different. Even though we are dealing with Boolean expressions, the coverage measures are different. The way we look at it, the perspectives are different. So, you cannot say the branch coverage, decision coverage, and condition coverage are one and the same. No, all three are different, even though all are focusing on Boolean expression. Condition coverage, we also call it as expression coverage, and it is one of the testing methods which is used to test and evaluate the variables or sub-expressions in the conditional statements. Okay, and what is the objective with respect to conditional coverage? It is basically used to check out the individual outcomes for each logical conditions. Okay, it is as good as going for decision coverage, but it offers more sensitivity to the flow of control rather than considering or going for decision coverage. When I have options for going for decision or condition coverage, it's better if you go for condition coverage. Okay, and in this particular coverage method, expressions with a logical operands. Okay, wherever I have made use of logical operands, only those expressions I am going to consider. Please focus on this word. Okay, wherever I have logical expressions and expressions are making use of logical operands. You know what do you mean by logical operands? Only those things I am going to consider for measuring condition coverage. Okay, after that, okay, so what all are the Boolean operations that I'm going to consider? I'm going to consider AND operator or XOR, which indicates maximum possibilities in a particular logical expression. Okay, then see, you need to differentiate between decision coverage as well as condition coverage. It will not guarantee the full decision coverage if you go for the condition coverage. Okay, it will not assure you about covering the complete source code wherein you are going to consider even the decision coverage. You cannot assume that if I go for the condition coverage, it will also cover the decision coverage. No, that is not the assumption. Okay. And the formula that we are going to use for computation of condition coverage is number of executed operands divided by total number of operands present in particular Boolean expression. Okay, that is the formula. Okay, as you can see, okay, the measurement formula for each of the coverage methods are different. Nowhere you are finding the same formula associated with each of the coverage methods. All are different. Okay, so here whenever you are dealing with condition coverage, make sure that the formula is different. The number of executed operands, because I am focusing more on the number of logical operands used in the expression divided by total number of operands which are present in the logical operation. So here the word executed is most important. Okay, how many operands have been executed whenever I supply an input value? for a particular code snippet. Okay, for that specific input, how many operands have been executed divided by total number of operands present in the source code. Okay, after that, we have considered one simple example. Here, if you see, it's a if statement. If x is less than y and a greater than b. Okay, total are the possible combination over here. As you can see, there are two expressions. It is going to be 2 raised to 2, 4 possible combinations. Okay, here this can be true and this can be true. This can be true and this can be false. This can be false. This can be true and this can be false and this can be false. So I'm going to get about 2 raised to 2 combinations because two expressions are present. Number of possible combinations for this particular AND is going to be 4. True, 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 false, false, true, and false, false. Okay, these are the possible number of combinations. Okay, and consider the following input for x and y. For x and y, what is that? X is 3 and y is 4. X is 3 and y is 4. 3, is it less than 4? Yes, definitely. So it gets evaluated to value true. Then I am considering it is true, that is 1 by 4, which is equivalent to 25%. If you just consider only this, the condition coverage for this particular logical expression. This particular logical expression, there are 4 possible combinations and only one I am exercising as per the formula, number of executed operands divided by total number of operands. That's why here the condition coverage with respect to this particular logical expression, it is going to be 25%. Suppose if A is equal to 3 and B is equal to 4. What is that? It is evaluated to false. It is evaluated to false. Okay. Here the condition coverage only with respect to this I have considered. So it is 25%. 25%. Here the number of executed operands, that is out of 2 operands, only one is been getting executed out of 4 operands. Okay, true and false. Okay, total number of operands are 4 here. Okay, 1, 2, 3, 4. How many combinations? Here it is true and here it is false. True, false. That is 1 divided by 4. That is 25% is the condition coverage. Okay, this is about the condition coverage. Okay, after that, let me tell you about one more thing. Okay, we have something called modified condition decision. In short, we call it as MC bar DC. Okay, MC stands for modified condition. DC stands for decision coverage. MC bar DC, modified condition bar decision coverage. Okay, it is basically designed for testing important combinations of conditions without exponentially increasing the test suite size or without increasing the test case size. We are going to consider only important combinations of the conditions for testing purpose. What do you mean by important combination and how you will get to know about it? Okay, in the source code, okay, you will have certain basic conditions which will have control over the code. Okay, and the outcome of that particular basic condition is going to impact or affect the outcome of each decision. Such condition I call it as a basic condition. Okay, in order to carry out this MCDC test coverage, what all things are required? Okay, I should have basic condition. I have to identify the basic condition in the source code. Then all evaluated outcomes except the basic conditions are to be the same. Okay, we look into that, how they are doing it. Modified condition, decision coverage, how it is being computed, we look into it. But what are the prerequisites for carrying out MCDC coverage? First and foremost, you should identify the basic test condition. and you are going to have two test cases for that particular basic condition, and all the evaluated conditions except the basic conditions, they have to be the same. Okay, and the compound condition, if there is a compound condition as a whole, it should evaluate to true for one and false for the other. That is with respect to the test case. If I have designed two test cases, then if I have a compound condition, then it should evaluate to true for one of the test cases and it should evaluate to false for another test case. These all are the prerequisites for carrying out MCDC coverage. Okay, and see, if I have n basic conditions in my source code, then the number of test cases that I am going to design to carry out MCDC coverage is n plus 1 test cases. You have to remember this. Okay? If I have n basic conditions, whenever MCDC coverage you are coming across, okay, then in that case, basic condition you have to remember. I have to consider, I have to identify the basic condition. If I have n basic conditions in the source code, then number of test cases that I am going to design, it is going to be n plus 1. Let me take up one simple example over here. This is the compound condition wherein I have written so many things over here. Okay, A or B and C or D, then and E. So totally there are 5 operands. Okay, totally there are 5 operands A, B, C, D, E. Okay, and these are the test cases they have considered. Okay, true, true, true. Then this is true. What is the outcome? See, A, B forming one thing, then C is forming another thing, D again, D and D together, this and this, they are together forming another thing. And what is the final outcome? That you are just looking at it. Okay, what is the final outcome that you are going to get? The underlined values, if you see over here, these will affect the output of the decision of this particular logical expression. Okay, these are test case numbers they have written. Okay, you can write any number. Here they have considered these test cases, that is test case number 1, 2, 3, 6, 11 and 13. Okay, so here if you check out, okay, this particular value, if it is true and this is true, okay, and what is the final outcome that I am going to get? Whatever values they have underlined, they are going to independently affect the final outcome of the decision. Okay, see here, if it is true, okay, A value is true, B value is also true, okay, A, B, C, D, E, okay, here dashed means I am not passing anything for B, okay. If I pass the value of B, see, here you should be very thorough with the outcome of the logical operator. When the value of OR is going to be false, whenever both the values are false, then only it will be false. Otherwise, irrespective of the value of another operand, if one of the value is true, then you know it already. The final outcome of a particular OR expression is going to be true only. Only if they both are false, then only the outcome is going to be false. That is not the case with respect to AND. If one of the value is false, then outcome is going to be false only. Outcome is going to be false only. Okay. OR and you should know the differentiation over there, how they are going to impact the final outcome of a compound expression. Okay. So you should be very thorough with the impact of each of the operator or operands used in the basic condition. Okay, so basically MCDC focuses on basic condition coverage and it will also consider the branch coverage. Okay, and here we'll check out how each condition will independently affect the final compound conditions output or outcome. Okay, so this is how we will be using MCDC coverage. Actually, this is not there for your syllabus. You have only those coverage methods. This is for your information. What do you mean by modified coverage, decision coverage, and how it will impact the outcome of compound conditional statements? Okay, MCDC, modified condition decision coverage. Okay, after that, this is very important. Path testing. What do you mean by path testing? You already know to draw the control flow graph, that is CFG, and you had indicated the blocks and you had connected each block via arrow marks. Okay. If I am traversing through each of the blocks, if I want to move from one block to another block, okay, if I pass certain values, input values, then I will be traversing through the graph via certain paths. Okay, and the testing of each path at least once, I call it as path testing. Okay, and it is also one of the structural testing methods that involves making use of a particular source code in order to find out each and every possible executable paths in CFG. Okay, you are going to look out for the executable paths for particular combination of input. Okay, see, suppose if there are any faults within your source code, then if you go for path testing, you'll get to know about the faults. Okay, if there are faults, then particular path cannot be traced out. That's how you'll get to know about the faults if you go for path testing. Okay, and this is basically designed to execute all or certain selected paths through the source code. Okay, and whenever in the program, if I have multiple entry or exit points, then testing of these points is very much challenging as well as it is time consuming. See, if you have multiple entry and exit points, you have to check out for each of the entry and exit points, which is tedious. It takes time. It takes time to test each of the paths which are present in the source code. Okay. In order to reduce the number of tests and if I want to achieve maximum code coverage, then I have to go for basis path testing. Okay, and we will look into this particular term in the next slide. What do you mean by basis path testing? Okay, basis path testing, it is one of the white box testing methods in which test cases are defined based on the flows in the CFG. Okay, and what is the objective of this basis path testing? Okay, why we have to go for basis path testing? It will define the independent paths which are present in the source code, and it will also tell you about how many test cases are needed. Okay, that can be defined explicitly to maximize the test coverage. See, the focus here is to test executable parts in the source code at least once. Okay, in order to execute or in order to test a particular executable part, you have to write the test cases in such a way that each of the executable parts which are present in the source program will be traversed at least once. That is the objective of having path testing. Okay, and paths, by doing so, you will have maximum test coverage. Maximum test coverage. Okay, and how can I do the path testing now? Okay, here if you consider, I think for everybody this is visible. Okay, this particular diagram, see here, I have the CFG over here, control flow graph, wherein I have indicated the nodes like this 1, 2, 3, 4, 5, 6, 7. Okay, what do you mean by first block? That is, I have a conditional statement over here. Then Again I have a conditional statement. Then I have simple statements over here. With this, let me explain you the path testing. Okay. There are certain conditional statements as I've already mentioned. Okay. Based on what condition we are considering. Here, there are three paths or the conditions that need to be tested to get the output. How many paths are there? Here, this is one path as you can see. This is another path. See here, I'll just show you it. Show you the number of paths. See here, this is one way of testing the path. One path. This is the second path, and this is the third path that is existing. So there are three paths existing in a particular source code, and we are supposed to test all these three paths via path testing technique. Okay, if you see here, what are the things? Node number 1, 2, 3, 5, 6, 7. Okay, same thing. 1, 2, 3, 5, 6, 7 is one path that needs to be tested. And there is one more path that is 1, 2, 4, 5, 6, 7. And there is one more path that is 1, 6, 7. So there are three paths that need to be tested to get a particular outcome. And what are the steps for carrying out this basis path testing? Okay, first of all, you should draw CFG in order to identify the paths with respect to particular source code. Okay, you have to draw the CFG. Okay, after that, we have to compute something called cyclomatic complexity to determine the number of independent paths in the CFG. Once I have cyclomatic complexity measured with me, then I can find basis set of paths. Then based on the identification of the paths, I can generate the test cases to exercise certain path in the control flow graph. Okay. What is the objective of having the path testing is that I am exercising the path via a test case at least once. At least once. That is the objective of having the path testing. Okay. And these are the steps followed in basis path testing. First and foremost, you draw the CFG control flow graph. Then you compute the cyclomatic complexity measurement. Then you will arrive at a certain set of paths. Based on the paths, you will design or generate the test cases to exercise or to traverse each path identified in the previous step. Okay, and I have one major over here measurement criteria or adequacy. Okay, what is that formula for finding out path adequacy? Okay, what is the criteria? Adequacy criteria. Adequacy criteria states that each path in the source code must be executed at least once. I am mentioning about this point again and again from that time. Okay, what is the objective of going for any of the testing method is each of the factor that you are considering, let it be a statement, let it be a branch, let it be a decision, let it be a path. Okay, with respect to path adequacy, you are going to exercise or execute each path at least once. And what is the formula for measuring path adequacy is number of executed paths divided by total number of paths in the source code. This is the formula for computation of path testing. After that, I have something. Okay, what are the advantages that are associated with basis path testing? Okay, see, sometimes it so happens that I'm carrying out the test again and again, which is redundant in nature. Okay, same testing is been carried out to test the same thing. I'm testing it again and again by generating the test cases. Such redundant activities can be eliminated via basis path testing. Okay, and here the main attention is on the logic of the program. Okay, and it is basically helps in facilitating the analytical, that is, the reasoning stuff will be given more importance rather than the syntax part of it. Okay, and the test cases which will exercise the basis set of paths will execute every statement in the program at least once. These are certain advantages that are associated with basic path testing. Okay, then I have something called loop boundary adequacy. Okay, what do you mean by loop boundary adequacy? Okay, it is one of the variations with respect to boundary interior criteria. Basically, it is associated with the loops. Okay, it is basically in association with the loop boundaries. Okay, then what is the criterion which is associated with the loop boundary adequacy? A test case. What do you mean by test suite? Test suite will have collection of test cases. Okay, test suite satisfies the loop boundary adequacy only if these statements are holds good. Okay, in at least one test case, the loop body is iterated 0 times. Okay, and in each of the test case, the loop body is iterated once. Okay, and you should have a test case wherein you can test if the loop body is iterated more than once. So you are checking out for these three conditions with respect to loops present in the source code. That is what I call it as a loop boundary adequacy. You should have certain test case which will test the loop body execution 0 times, that is getting iterated, or exactly once the loop body is getting executed, or more than once the loop body is getting iterated. Okay, loop is always in terms of iterations, right? Repetitions. Okay, so what is the criterion that should be satisfied by the test suite is that these three should be hold good. Okay, you should have one test case in the test suite which will test for 0 times iterations of the loop body, and you should have a test case wherein you are going to iterate the loop body exactly once, and you should have a test case wherein the loop body execution or iteration will be more than 1 time. Okay, and these are corresponding to the cases. Okay, that is, it will provide you the proof with respect to the correctness of the loop body or the loop constraints you have written. Loop boundary adequacy basically deals with the loops in the source code, and it focuses on the logic associated. Logic associated. Okay. In short, I call it as LCSAG adequacy. What do you mean by LCSAG? That is linear code sequence and jump adequacy. This is loop boundary adequacy, whatever we have studied. Extension to this is loop, linear code sequence and jump adequacy. Okay.